All right, geometry, here's our second lesson for week 2, and that is calculating the volume of three-dimensional figures. If you did not already see the classifying three-dimensional figures, go back and watch that first. All right, so looking at this, if you think of volume, volume is really the space contained inside of a three-dimensional figure. If you look in your pantry right now, you're going to find that there's volume measurements on pretty much everything in your pantry. Just look on the lower right hand or left hand corner and you'll see that fluid ounces or how many grams it has. That's more of a weight measurement. But when you're looking at liquid, you'll see that there is a volume measurement on the container itself to tell you how much is inside the container. Because if you look at different shapes of like olive oil, the bottles are going to be a little bit different for each one. Another visual representation of what volume truly is, or how to why we have formulas for it. If you were to think about a cylinder, I'm going to use a cylinder as an example, but you can do that for all of these. A cylinder, if we were to take the formula for a cylinder, notice how we have the area of the base, which is we're gonna use capital B to represent the area of the base. And the area of a circle is pi r squared. So that's going to be the area of our circle right here. And then we're going to multiply it by the height to end up finding the entire volume of the cylinder as it continues on. Now, if we multiply by the height itself, notice how it's kind of like we're going to have pancakes here, all stacked, and we're going to find the area of each pancake and add them all together. And that's going to give us the total area of the entire cylinder, and that's what we're looking for. Because remember, area is different. Area is looking for the the space of a two-dimensional shape, whereas volume is three-dimensional. We're going to end up having content inside the cylinder that we can find the actual volume of. All right, so I'm going to erase this a little bit because it's gone crazy. Here we go. Okay, so for today's lesson, we're going to go back and forth to these formulas, and you're going to see how to calculate the volume of these different formulas for these different shapes. Now, what we have here is a rectangular prism. Now you might also see this formula, the volume equals the area of the base times the height. And that's going to be true for every single formula. So notice how on other prisms, it's volume equals the area of the base, so the capital B times height. That's also going to work for this rectangular prisms or cubes. Cylinder, notice how its volume equals area of the base times height. That still works here. It does change though when you're working with pyramids and cones. Now pyramids and cones, if I was in the classroom, I do have a shape, a container that I usually pour water in, and I can show you that it's gonna end up only being 1/3 of the actual space of, say, if we were working with a pyramid and we had a rectangular prism. If that pyramid was inside the rectangular prism, it would only take up 1/3 of that space, and there would be 2/3 of empty space around that pyramid. And the way that I would show that is I would fill a rectangular prism up with water, and I would pour the pyramid into the rectangular prism, and that would show I would need 3 of those in order to make one full rectangular prism. I'm going to see if I can do that for you, and I'll post the video after this, right under this, and also with cones as well. So I'm going to see if I can do that. All right, so let's go ahead and first start talking about the steps for finding the volume of a three-dimensional figure. They're written out here, so you just have to, I'm going to try the highlighter feature here and see if I can read them out loud for you as I follow along, okay? So the first step is we're going to go ahead and identify which of the three-dimensional figures that you're working with so that you can write down the formula for that shape, okay? So if you're working with a cylinder, use the cylinder formula. If you're working for pyramids, use the pyramid formula. Remember, capital B just represents the area of the base. Okay, next you're going to substitute the height. Hello. It doesn't like me now. Okay, you're going to substitute the height into the formula, please remember that capital B represents the area of the base. A lot of people forget that. That's why I've stated it multiple times. Okay, for step 3, we're gonna, the area of the base, seeing the substitute of the equation, and then you multiply everything out and don't forget your units. So, over on this side, we have a rectangular prism. And we're gonna go ahead and calculate the volume for this one. Okay, so first we need to find the formula for the volume of a prism, which in this case is gonna end up being volume equals the area of the base times the height. Second, we're going to substitute the values in for the height first. So that's going to end up being the volume equals the area of the base, we'll take care of that in the next step, times the overall height. Now, since I'm stating that this is going to be my base, then my height is the distance between my two parallel bases. So this height is really going to, this height is really going to just end up being 2. All right, next we're going to substitute an expression for the area of the base. Now, the area is 6 times 6.2. So when I substitute that in, we're just going to end up with our formula is volume equals 6 times 6.2. And then we're going to multiply by our height, which is just 2. So once all of that is multiplied out, you should end up with a volume equals 74.4, and then don't forget your units. Whenever we're working with volume, it's 3-dimensional. We multiplied 3 dimensions, which would have been centimeters times centimeters times centimeters, which would end up being centimeters cubed. And then that's how you would find the volume of a rectangular prism. Okay, so let's go ahead and take a look at if we had a triangular prism. Okay, so if we're given a shape and we're not quite sure what it is, we always take a look to see what the shape of the base is. In this shape, it is a triangle, so we're going to end up having the area of the base, so volume equals the area of the base, which is capital B times the height. So if we are, so first identify the base. Since the base is a triangle, I know that this is going to be a triangular prism. The area of the base for this one is going to be a triangle, so the formula is going to be base times height divided by 2, and that's just the area formula of a triangle, so triangle area. So looking at this, we need to find the height, which is always perpendicular to the base for the triangle, and so volume equals 3.6 times 10 all divided by 2, and that's just going to be capital B, the area of the base. Boop. All right, and then our height, which is always going to be the distance between the two parallel planes, or triangles in this case, which would end up being 5. So 5 represents our height for this figure. After you multiply all of this out, your end volume should be 90 meters cubed. Now, when I say multiply this out, you're always going to start with your numerator first, so 3.6 times 10, and then divide it by 2. After you get that value, multiply it by 5. Sometimes students put in the entire function into the calculator, but order of operations, the calculator is going to do exactly what you tell it to. Okay, and sometimes you might calculate it wrong because you're missing parentheses or something like that. So just use order of operations. Numerator first, simplify, divide by 2. Once you have that, press enter. Then you can go ahead and multiply the whole number that you have here by 5. All right, so, okay, we're going to go ahead and find the volume of a cylinder. Hold on. And the way that we're going to do that is first start off with the volume formula as far as volume equals the area of the base. So area equals the base times the height. Now the area of the base is this, in this case, because it's a cylinder, it's just going to end up being pi r squared. And then we're going to multiply it by that height, which in this case the height is 19 because that's the distance between. Make this a little bit thicker. There we go. Whoop, too much. Okay, so whenever we have the volume, we're going to calculate this both ways. I'm going to show you how to find the exact answer using pi, and then we're going to use 3.14, and then I'll also use the calculator button to give a more precise answer. But we first need to figure out what this radius is. The hole diameter is 13, and we need to find the radius. Now the radius is half of 13, which is just going to end up giving us 6.5 millimeters for our radius. And don't forget to square times the overall height of the figure, which in this case is going to be 19. Now for an exact answer, to leave in terms of pi, we would end up multiplying 6.5 squared times 19, and we would end up with 802.75 pi. Now that's an exact answer, or in terms of pi, if something asks for that. If I were to use pi as approximated to 3.14, then our overall solution is going to end up being 2,520.64 millimeters cubed. All right, now if we were to use the pi button, which if you look at the answer key to any of these problems worked out, you're going to see that it's going to end up being this answer. So that would be 2,521.91 millimeters cubed. So it's okay on these worksheets that if you have a different answer and it's just slightly off by a few numbers, that is okay, because the approximation of 3.14 is not exact as your calculator key can get with pi on the calculator. All right, so let's go ahead and take a look at the volume formula for a pyramid. I'm going to pause it and go ahead and work out the work and then go ahead and explain it. Okay, so for this pyramid, we notice that this is going to end up having a area of the rectangle because it's a rectangular pyramid. So the area of the base is going to be 10 times 11 times our height. Whoops, don't forget the 1/3 because we are working with a pyramid. And our height for the pyramid perpendicular to the base is going to end up being 16. All right, now if you're using a calculator at home, go ahead and multiply 10 times 11 times 16. Once you have that overall answer, divide by 3 or multiply by 1/3, whatever you feel most comfortable with. Your overall volume for the pyramid should end up being 586.67 inches cubed. Okay, let's go ahead and take a look at how to calculate the volume of a cone. So whenever looking at a volume of a cone, our formula is still going to be 1/3 times the area of the base times the height. But the area of the base of a cone is pi r squared, which is our circle formula. So we would end up with the volume equals 1/3 times pi. Now our radius on this one, they gave us the radius, awesome. So that's going to end up being 3 squared, that was terrible, times the overall height, which is going to end up being 8. Okay, 3 squared is going to end up being 9. 9 divided by 3 is just going to give me 3 pi times 8, which 3 times 8 is going to give me 24. So 24 would be our exact answer. Okay, if I were to use the pi button on the calculator, that would end up being 75.4 kilometers cubed. If I was using 3.14, that's going to end up being 75.4, nope, sorry. That's going to end up being 24 times 3.14, which would end up being 75.36 kilometers cubed. So you could end up with one of these three answers. This would be in terms of pi, which is the most exact answer. And then this is using the pi button on the calculator, and this is using pi, which is equivalent to 3.14. Okay, I hope this clarified some things. I'm going to make a video for the optional practice below. If you're still stuck on something, please come to one of the Zoom tutoring sessions. Otherwise, have an awesome day, and I hope you guys are doing well. Have a good day. Bye.